Good evening, students. Today, on behalf of Cosmo Championship and the Agathiar Rocket Science program, so today we are about to pay tribute to Bharat Ratna Dr. APJ Abdul Kalam. So, in this regard, we are about to play some videos until Pillai sir is about to join. So, you can just watch. Thank you.
ஐயா வால்யூமே கேட்கல, சவுண்ட் வரல.
ஐயா வாழ்வை மீண்டும் தந்தாயையா. Scientists and poets. This is unique. Pillai.
நீ பெண் கலைஞன் நிரந்தர இளைஞன் ரசனை மிகுந்த ரகசிய கவிஞன் நீ பெண் கலைஞன் நிரந்தர இளைஞன் ரசனை மிகுந்த ரகசிய கவிஞன் போற்றி கொண்டு உலகத்தில் இன்று ஆயிரம் பிறவி கொண்டாய் பாட்டில் ஆயிரம் திரைகள் கண்டாய் சோதனை உன்னை சூழ்ந்து நின்றாலும் சோதனை முயற்சி சோர்வுறவில்லை ஆய்ந்து முதலி ஆடி வந்தாலும் ஆக்சிஜன் குறையவில்லை சொன்னாரியே ஆண்கள் தூக்கமில்லை மேலும் உன்னை மென்றிட பெற்றதன் பெருமை கொண்டு உலக நாயகனே We'll call you back.
Hello.
Sir, good evening, sir. Good
Good
evening, sir.
evening. Will you start? 6 o'clock.
Yes, sir. Yes, sir. Sure, sir. So we thought that you can just speak out some words to tribute to
Yeah,
Kalam
yeah.
sir, sir.
Yeah,
Yes,
I
sir.
will talk.
So
I'll talk about
we just created one poster, sir. So I'm just sharing it.
it.
So this is the poster, sir.
Okay.
Yes, sir. Please, sir. You can talk, sir.
Right. You can remove that poster. That only.
Yes, sir. Yes, sir. Yes, sir.
Now I will share my slides.
Sure, sir.
It's not coming. Sharing is not turned on. Sharing is not turned on.
Kabilan,
So it's done, sir. It's open.
It's not coming.
make sir as a co-host. Kabilan?
Oh, it's done, sir.
No, it's not actually.
Yeah, it has
Yes.
done. Yeah, it has.
Yes, now. Yes, thank you. Thank you.
Okay, good evening, guys. I think our strength is about 150 if the students are there. So good evening, students. So today, you know that it is 27th of July. We remember our great role model, Dr. APJ Abdul Kalam. You know what? Who is Dr. Abdul Kalam? Was uniquely combined a single lifestyle with a strong willpower and a bold vision for developed India. He lived an illustrious and successful life, and his legacy will continue to inspire people like us around the world for years to come. Dr. Kalam is living in the hearts and minds of all of us, all the Indians, all the youth in the world. He will remain one of the finest human beings to have ever lived on the earth. He is a Brahma Rishi. As a Brahma Rishi, he is immortal. So we remember this day, the 27th July 2015, the 10 years have gone. So we remember him for his great contribution to the nation and for the development of the youth. We are all inspired by him. And all these things that what we are now interacting is all because of him. He only guided the youth development, used the youth for developing all the technologies, and he demonstrated the launch vehicle technology, missile technology, nuclear technology, and above all, he gave a vision to the nation. So we are all very proud of him for his contribution, and we remember him on this day. So in his name, we'll start the course today, the third lesson today. So he is a mission man. Dr. Abdul Kalam is a mission man. He doesn't see only one part of the side. He looks at the total. Let us look at the total of our purpose, that is studying the rocket science. Rocket science, when you say, it is a launch vehicle which puts the satellite in the orbit, and the orbit, it goes in the orbit, and its purpose is to, say, monitor the earth or give the communication. And during this whole course of putting it in the orbit, you need a mission operation. Many people have to work in the control center to check out the system, make it working, and then launch it. And also you need many ground stations all over the world to see that where it goes, real-time monitoring. So this is called tracking as well as the telemetry. Tracking means that the whole mission, what is taking place, is tracked by the radars, and there are telemetry stations which receive from the rocket the parameters. That means this rocket, when it is launched, it is totally instrumented. So these instruments details are combined at a telemetry, and there's a telemetry. Tele means distance. So it communicates from the launch vehicle to the ground. That unit is in the, it is there in the payload. It is there in that, we call it as a equipment bay, which is there at the top where the onboard processor, telemetry, tracking systems, all onboard systems are there. So from there, you communicate to all the ground stations, and ground stations communicate to the control center where we monitor, and then real-time trajectory is told us. We said about trajectory. What is trajectory and what is orbit? You know, there is a difference. One is called trajectory. So what is orbit and what is trajectory? When you talk about a satellite, which is orbiting around the Earth to do certain purpose, navigation, communication, or remote sensing, whatever the purpose is there. So this, when it goes in a particular path, this path is called orbit. Okay, this is the path exclusively for the satellite to go. Okay, so when we say trajectory, it is for the launch vehicle path. That is when it is launched, it takes off, then it goes up, gives certain velocity, then the first stage separates, first stage goes and then it falls, in a trajectory it goes, and then the second stage burns, and then finally it is injecting the satellite into the orbit. So this path, what you are seeing, it is called trajectory. So launch vehicle has got trajectory and satellite has got orbit. So these are difference. So when we say orbit trajectory, you should understand what we are saying. The path followed by a launch vehicle is called the launch trajectory. Let us understand more about launch vehicle trajectory. This is a GSLV, geosynchronous launch vehicle. When we launch from Sriharikota, first the core stage, it ignites. So there's a strap on to that, which you have seen last time I showed you yesterday. The strap on ignites and push it, the rocket goes up. With the full speed, it goes up. And finally, it gives certain velocity at a point. When the second stage gets ignited, and the first stage, which is burned out stage, is separated. So now it is second stage operates. So part of the launch vehicle only goes up. So second stage goes up. It has gone beyond the the atmosphere. The pressure, direct pressure acting on the launch vehicle is much less. So then we separate the heat shield, and then again it moves, that the protection of the satellite is not required anymore. So the payload firing is separated. Then the second stage completes its operation, and the third stage is called cryogenics upper stage. That starts burning. So second stage separates, cryogenic stage burns, it takes it to a very long distance. It's a coast. This is a very long distance it burns, and to give the velocity. It is not, the altitude is not important because you have reached the altitude. What is more important is the velocity. Velocity we have not achieved yet. So the cryogenic thing burns for a long time and it gives the required velocity. Once the velocity is reached, the cryogenic stage cuts off this propulsion, and then you separate out that GSAT. GSAT is a satellite. Satellite for geostationary orbit. It is removed from separated. So now the purpose of the launch vehicle is over. Now the satellite has to take over. Okay, so that is what recorded here. If you see, stop on ignition, core stage, then core stage. Core stage, it takes it to the altitude. Then strap-ons are shut off, and the second stage separates. Ignition starts. The first stage separates, and then the payload payload firing. The heat shield is removed. Then the second stage shuts off, separated. Then cryogenic stage starts, ignition, and then it burns out, and then the satellite is separated. So it takes 17 minutes total time to separate the satellite, and here the orbit is around 200 kilometers. What do you mean by 200 kilometers? It is the injection point, but whereas it has to go to 36,000 kilometers. So you put it in a very highly elliptical orbit of 200 by 36,000. So that minimum distance 200 is called perigee. and the long distance 36,000 which goes around, that is called apogee. So there's an elliptical orbit around the Earth. The distance between the center of the Earth and to the satellite. Actually, we take from surface to the satellite is a 200 kilometer. That is called perigee. And the Earth to the long distance, it has go, that 36,000, that is called apogee. At the apogee, we give another thrust, another propulsion is fired to correct it to the circular orbit. Then it goes in 36,000 kilometers orbit. So it is here also, it is the same thing is explained. First stage burnout, then the second stage burnout. All these things are explained here. Actually, this is the recovery of the booster. This is a new concept which Elon Musk has brought in. So here the first stage burns out. Okay, it can separate, it can go down. But what he does instead of separating and going down, he takes it, turns it, and he makes it, it has got its own propulsion. He recovers the whole booster down, and it can nicely come back to the land near to the launch pad. So this is a new concept he brought in that is called reusability of the booster. This recovery. Okay. So this there was a question yesterday. What is called azimuth? Why azimuth is important? You see, this is the launch site. This is Florida. Kennedy Space Center is here. This is the Kennedy Space Center. This is what you see is the America. Okay. This is the Kennedy Space Center, from where the Elon Musk is launching the Falcon. The Falcon goes up in a particular orbit, a particular direction it moves. This is the ground trace of the Falcon. You see that. So there is no land in between. That is, we select the angle of launching to a safer place. So this particular direction of its going, that is the ground trace of the launch vehicle, the sequence is called the azimuth. It goes like that. Azimuth should be selected such a way it is safe. It should not harm any other country. Okay. That's a point which I thought I will tell you. So in India, if you see, we have got a launch station called Sriharikota. It has been named after Satish Dhawan. It's called Satish Dhawan Space Center. Mr. Gogol, who is now in our, is there, he is working in, he is ISRO engineer working in Sriharikota. So the Sriharikota is where it is north of Chennai, nearly 100 kilometers away. There's an island. This is an island. What you see is an island, some 40,000 acres island. So it's a safe place. It is 17 kilometers separated from the mainland. Mainland place is called Sulurpata. There's a Sulurpata, that is a place from where you have to go. The path has been built by ISRO to go to this island. So this island is safer place where we can do the launches. First in the island, once you enter there, you will, this island, you can see this is the island, this is the island part. This is a Plicot Lake, there's a lake there. And then this is the mainland of the mainland of India. Now, once you enter there, there's a very good exhibition. All the space activities are there. There's all the students who go to Sriharikota, first they are taken to the exhibition center to understand what is space program, what all the things have been done, what is launch vehicle, what is satellite, everything is explained here, and they show different launches, videos are all there. You can also play the videos. So this is a place. Now the main place where we have to go is called the control center. This is a control center. There's a huge building, a semicircular building. So you have to climb up to that building, the top, the operations they do, where you will see that all the operating engineers sitting there, to do that. We have seen that in the video yesterday. So then there are launch stations from where the PSLV, GSLV Mark III, the bigger one, LVM3, all these things are launched. So the number of launch pads are there, which are much separated from here. So more than 8 kilometers away from the main place, because for the safety reason. So once if some of you go there, we'll take you to the launch pad to show you what is the launch pad, how it is going to be, how people operate. And then there are many stations which are called telemetry and tracking stations, where they are very important to get the information about the launch. So this more explanation about the site. This one, these are the launch pads. Here are the launch pads. Then here is this propellant plant, big plant where Mr. Gogol works. Then we have got the static test area, and then number of other launch stations are here. So it's a huge place to go. This is the whole island is here, and the control center is somewhere here, away from the main thing. Now, if you look at this, I have drawn one more thing to explain to you about the trajectory. We are on the subject of trajectory. So PSLV, if you launch from Sriharikota, we are launching the satellite to polar orbit. That means pole. It has to go to the South Pole and then come to North Pole like that. So satellite should be injected in the direction of the pole. But pole means it is here. So what you have to do? You have to turn the missile and go to that. This one. Why you have to turn? Because Sri Lanka is here. You cannot launch straight. If you launch straight, it will be overflying Sri Lanka. In case of any problem, there's a failure of any system, it will fall on on the land. So that's not accepted internationally. We should not harm anybody. So we have to go around. This is called dog leg maneuvering. Because we are going around and turning the launch vehicle, we are losing nearly 20 to 30% of the capacity of the launch vehicle. That means the satellite size will be reduced because we are doing a maneuvering. That means you are spending energy to do the maneuvering, so you lose payload. So there is a need for going directly from the south. So we are building another station in Kulasegarapatnam, that is near Tuticorin. There is a new one more station, launch station is coming up now, from where you can directly launch. That means you will save the satellite weight. Satellite weight is very, very important. So that's what we are trying to do that. So you see that how the trajectory matters. Trajectory should be safer. If you want to do the geosynchronous orbit, you have to go near to the equator. So you launch from here like this, you launch and go to the equator. That's what we do it. This is not possible. From here, you cannot do geosynchronous launch vehicle. Again, Sri Lanka is coming. So for geosynchronous launch vehicle, that means communication satellite, will be using SHAR, and for polar satellite, we'll be using this near news site called Kusharpatna. Okay. So these are the stations which I told you that people will be operating inside the control center. You can see multiple centers are there. Each one is monitoring, some monitoring about the launch vehicle, some monitoring the downrange stations. So all these things should be ready for launch and countdown, then trajectory and displaying the trajectory. So there's a range director who will be operating the range requirement, and there's a vehicle director who will look after only the vehicle requirement. Then that's
Villain? The villain?
Sir,
சாருக்கு தான் சிக்கலா?
the signal நான் நினைக்கிறேன்.
Okay.
பாலா சார்.
சொல்லுங்க கோகுல் சார், சொல்லுங்க. சரக்கு அடிச்சிடுறீங்களா இல்ல நான் அடிச்சிருவேன்? Students, actually, there is some internet issue at SAR's end, so he would join in 5 to 10 minutes. So until then, we can view Kalam Sir's video. One moment, please.
பரவ ஓட்டத்தான் தேர்வு ஒண்ணு எழுதுனா இறுதி சுற்றில் தோத்துத்தான் சோகத்தில திரும்ப படிக்கணும்னு ஆர்வம் அவனாட வேண்டும் தூக்குச்சு தோல்வி கூட வெற்றிதான் அன்னைக்குத்தான் தோணுச்சு எடுக்காத எழுத்துக்கிட்டு மேக மேல ஏறிக்கிட்டு பருந்து ஒண்ணு பறந்திடத்தான் பார்த்து நின்னாடே பறவைங்க எல்லாம் மழைக்கு கீழே பருந்து மட்டும் மேக மேல மனசு உயர வார்த்தை உயர மாற்றி சொன்னாரே செய்தித்தாள் போட்டவரே தலைப்பு செய்தியான கதை குடியரசு தலைவராகி குடியேற்கிறது இந்த கதை உலக நம்ம என்று பார்க்க தலை நின்று நாமணி இளைஞரெல்லாம் வெளிச்சு கனவு காணுக்குள்ளோம் இந்த கதை கனவு பிடித்து செய்வது கனவு இழித்திருக்க செய்வதே கனவு பிடித்திருக்க செய்வதே கனவு பிடித்திருக்க செய்வதே கனவு
ப்ரோக்ராமிங்னு எல்லாருமே சாஃப்ட்வேர்.
ஹலோ So, can I join now?
Sir, you can present your slide, sir. Yes, sir.
Okay. Okay. Is it visible to you?
Yes, sir. It's visible, sir.
Okay. We are going to talk about the rocket. I'm talking about the propulsion. You know, when you talk about a rocket, it has got the main chamber where the propellants are there, which gives you the required velocity by burning. So that is called propulsion. This is a very important thing. So it has got control, guidance, onboard electronics, satellite structure, all those things are there. First, let us learn about the propulsion. So propulsion means what? Initiating or changing the motion of a body. So the thing what we want to study is the space propulsion, which is the rocket launches, controlling the satellites. That's also done by the propulsion. Then maneuvering of the spacecraft is done by the propulsion. So this is the what is called action reaction, which we have seen. So launch vehicles, we have seen launch vehicle space propulsion is used. Ballistic missiles, it is used. Then Earth orbiting satellites, the propulsion is there. Different upper stages, it is there. Then interplanetary spacecraft, all these things are there. Okay, manned space flight, space station, everywhere the propulsion is there. Okay, that is why propulsion is very important. So primary propulsion is for launch and ascent, to go up, ascent. Then maneuvering, orbit transfer, station keeping, trajectory correction. Then there are auxiliary propulsions for attitude control, reaction control, momentum management. All these things are also done by the various propulsions in the different types of orbits. You will see that the reaction controls are used. So overall, if you take propulsion, there is one thing called stored gas. It's a cold gas, and it is used for pushing. That is, you fire, they use that one to maneuver. It's a very big thrust cannot come. But chemical propulsion is the one which gives the big thrust. In chemical, we have got solid, liquid, hybrid. These are the three components. Solid propellant means inside the propellant is just a solid block. Liquid means it is stored in a liquid form, and it can be storable liquid or it can be cryogenic liquid. That means it's liquid oxygen, liquid hydrogen. If it is there, they are called temperature fluids. They are called cryogenic fluids. Then hybrid means solid and liquid combination. So this is a very, very important thing which we are going to learn. So here it can be liquid, can be pressure fed. By pressure, you can push the liquid, or pump, turbo pump can be there to push the liquid. There can be monopropellant, bipropellant. That is, monopropellant means only one propellant. There's a catalyst to operate that. Bipropellant means there is a fuel and oxidizer, which we talked about it. This is one type of propulsion. Another type of propulsion is called electric propulsion. So electric propulsion, there are three types: electrothermal, electrostatic, and electrodynamic. There are three types. These are called electric propulsion. Then advanced propulsions are there, which are called nuclear propulsion, solar thermal, laser propulsion, antimatter. These are the very advanced propulsions. So we will be going through all these types of propulsions in course of time. Okay, now, what is stored propulsion? That is just it is there in a gas, it's a cold gas. It is called propellant tank. From here, you just push it down. But it is under pressure, so it will flow quickly to the thruster. So there are many controls are there to flow control. You can't release it just like that. You have to release it based on the requirement. So that is why all these controls, filters and all there. There's a regulator which controls the flow. This is the type of propulsion is called primary propulsion. This is the high pressure gas, and the gas is released through the nozzle. Nozzle, you can see the down, and the currently used for momentum management of the space telescope management. You need only gold gas. You don't take bipropellant or heavier high efficient operation. You don't do it. You should do it very slowly because they are in the orbit. So you need only little force to control that. So propellant like nitrogen, helium, nitrous oxide, butane, these are the ones used for stored gas propulsion. Then monopropellant system, which I told you, it has got a very efficient fuel called hydrazine, and it has got the helium to, nitrogen or helium to support the hydrogen. But when it flows through, this is the main propellant. When it flows through, you need a proper catalyst to do the work. So these catalysts are, embedded in the thruster. So the flow takes place. The nitrogen or helium is under pressure. Is under pressure. They are called pressure bottles. High pressure, 400 atmosphere pressure, it is kept. And then this is only pushing the hydrazine. Hydrazine is stored, no pressure there, but this pressure in the nitrogen, it pushes it down when there's an operation requirement. Then it is controlled and it flows to the various thrusters. So these are the called monopropellant. Normally hydrazine is used. N2H2, that is the hydrazine. And they use typically the operation is called blow down because the pressure from the hydrogen, the nitrogen or helium is used to blow down. So it's called blow down mode operation. Then bipropellant, there's a fuel and oxidizer. Separately, they are there. They are allowed to go inside the combustion chamber, and then it is the thrust happens. So here, a fuel and oxidizer both are used through an injector, and this is hypergolic. Hypergolic means instantaneously they will burn put together. There's no ignition required. Automatically it will burn. But when you use cryogenic type of propellants, the fuel and oxidizer, they are different. There's an igniter required because the oxygen is minus 423 degree Fahrenheit and hydrogen is minus 297. So you need an igniter to make the combustion. Otherwise, storable propellants, there is no problem. We can do immediately. But there is another thing called semi-cryogenic. That means the kerosene is used as a fuel, and then you use some other oxidizer to do that. So one is called cryogenic, that is liquid oxygen. Another one is kerosene. So when you have got cryogenic plus fuel, non-storable propellant is used, it is called semi-cryogenic. So what is happening is here the fuel and oxidizer, they burn. This I have shown you earlier. They through the turbo pump, they're pumped inside the combustion chamber, and then they burn. Then the thrust gets formed. So this whole thing, combustion, is called hypergolic. Hypergolic means it burns immediately once they meet together. A combustion takes place. So the big engines, there are the big engines are there. Saturn V engines are very big, where the thrust level you can see that 1.5 million pounds thrust it gives. This is LOX cryogenic, that LOX kerosene, which is called semi-cryogenic. It's a semi-cryogenic engine. You can see another main engine of the space shuttle, that is cryogenic, LOX H2. Here also the thrust is very high. And then you have got this is the Russian LOX kerosene semi-cryogenic system. So there are many types of engines are there in the world, which are very, very powerful engines. The thrust level, if you see, they're very, very powerful. The 1.78 means nearly, very high million pounds thrust. It gives is a huge thrust, and there are number of them together. That means they are called clustered engines. Many engines are together. That means you thrust you multiply by the number of engines, so that much thrust you can generate by the engines. So, but in the solid, you don't need all these things. Where solid rocket, they give a very high thrust level it gives, and it is in a chamber which is high pressure chamber. So the chamber has to withstand the liquid stage. You have to only store, and you don't need that much strength of the material. So aluminum is used, aluminum alloy. But whereas in the solid, we used steel, high strength steel like barraging steel, or there are a number of them, 15 CDVC. So many steels are there which are used to give the high strength. And inside, if you see, is the propellant. This is the propellant, you see, the propellant. Between the propellant and the casing, there is one hatch, you see, that is called insulation. And inside this shape of the propellant is like this. A particular shape is there. So the purpose of the shape I will tell you. So and then you need igniter to ignite. This igniter is there's a hole inside. Whole thing is a hole. So when ignition takes place, there's a propagation of the flame throughout. That means the whole thing burns, vertically like this. It's a called web burning. This is called web. Web burns radially, and the exhaust comes out. So there's a nozzle. This nozzle has got convergent, throat, and divergent. So all these exhaust is converged, pushes through the throat under high pressure and diverges. Then the pressure becomes low and velocity increases. So this shape is decided for attaining the required velocity level for the rocket. So this is the type of thing which we use as the booster. You can see this is the SLV3 booster, which is a 10 ton of propellant in 3 segments. It is there 3 segments assembled together, and it has got this shape for SLV3. Now what we do, we make the solid propellant we make. Then before we go for flight, we have to put that in a stationary bed, is called test bed, and then fire them. So it is first you are trying to see whether it burns as per the requirement of the thrust time. In a mission, if you do a trajectory, that trajectory requires a particular thrust time pattern. So that thrust time pattern is measured by firing on the ground. This is a big rocket you can see, a huge rocket. This is 138 ton of propellant. This is the booster used for the PSLV. And you see this generates for 443 tons of thrust it generates using high, this is called hydroxyl terminated polybutadiene, the propellant. And this propellant, solid propellant, burns, and then you see how much it is giving the pressure time as well as the thrust time. So this thrust time is very, very important. That should be confirmed by firing 3-4 rockets on the ground to prove that the system will work. So the whole 100 seconds, if it has to burn 100 seconds, full 100 seconds, it has to give the performance. So this is called static testing of a rocket motor and proving it on ground before doing the flight. And next is the cryogenic engine. You see LOX cryogenic engine, LOX and LH2, liquid hydrogen and liquid oxygen. So this cryogenic stage is also very, very important. So these are the engine testing, which we do it for the third stage of the GSLV. So here they burn, hydrogen comes here, oxygen comes here through their turbo pump. They come, there's ignition takes place. Ignition is already there. So you have to create an ignition before they flow, and then the thrust gets formed. This is the combustion chamber, and this is the final nozzle. You can see that engine. This is engine. This is the diversion portion of the engine. These the turbo pumps are sitting here. And then this combustion is here. Combustion chamber is this. So it burns like this, and while taking the satellite. The satellite is up. So the engine, this is the engine which takes the rocket up. So when we do all these things, you have got a different specific impulse. That is the energy. Energy is termed as specific impulse. What is specific impulse? There's a total impulse which is generated by the total kilogram of propellant. So kg second divided by kg weight gives you in terms of second. That is called the specific impulse. Specific impulse is a measure of efficiency. If you look at it, LOX cryogenic efficiency is very high. Yesterday, one student asked the question, what is the difference between the different types of propellant? So if you see normal solid propellant is nearly 300 equivalent seconds, 300 units you can take. When you go for LOX H2 cryogenic, in 450 seconds. So 1.5 times it is better. And normally it is used as an upper stage so that the final efficiency you get more on the payload. So specific impulse depends on altitude, nozzle expansion ratio, mixture ratio of the propellants, and the combustion temperature. These are the factors which determines the specific impulse. So in the small thruster, this is a small thruster, you see, that small thruster. Here the specific impulse is to monopropellant. This is a monopropellant thruster. We have used monopropellant thruster in the SLV third stage. We have used it. That has given a very low efficiency of nearly 230 seconds. These seconds are in the vacuum level, but in this, when they operate in the sea level, it will be much less. So now we are in the GSLE Mark III, which is there. There's got two big strap-ons. You can see the big strap-ons. This each one carries 200 tons of the propellant. 200 tons of propellant. You see imagine how huge it is. So 200 plus 200, 400 tons of propellant burns at a time to lift this weight. So you have got a very huge rocket. If you want to take, you need more thrust to be imparted at the time of takeoff. So 200 is 200. Then the liquid, this is the liquid stage, storable liquid, UDMH N2O4, which gives 110 tons of fuel it carries. 110 fuel, tons. Then you have got a cryogenic stage, upper stage, which carries 25 tons of the fuel and oxygen. Liquid oxygen plus liquid hydrogen put together is 25 tons. So this is the configuration. When we say configuration, we always say with respect to the weight, 200 tons, 2 into 200 tons, 110 ton, the liquid stage, cryogenic stage 25 ton. Now we are also moving to next stage. Next, whatever we are flying is this. Next type of launch vehicle is going to use semi-cryogenic stage. Instead of the liquid, storable liquid, we'll be using semi-cryogenic engine, SC, semi-cryogenic, 160 tons of the fuel. Semi-cryogenic means what? It has got liquid oxygen and another either kerosene. Kerosene means not what we use, it is a aviation kerosene or propane. There are different types of, your CH is there, different carbon, hydrogen, CH based material, methane, you have got hydrogen, you have got different types are there, which have got hydrogen and carbon. So that is the one which is used as the fuel, and it is the oxidizer is liquid oxygen. So then it becomes a semi-cryogenic. Cryogenic is liquid hydrogen, liquid oxygen. Normal one is the other fuel which is used like methane or propane or something else, or kerosene. And it has got again the two rockets to lift it up. So we are replacing storable liquid to semi-cryogenic liquid. What is the advantage? Storable liquid, if it gives 300 units, this will give nearly 400 units it will give. But the upper stage will give 450. That is the cryogenic. Okay. So when we do that human space program, what is required is this type of launch vehicle should be man-rated. What is man-rated? The man is going to be there inside. So all these vibration and the different levels which are important during the launch, shock, vibration, different types of environment, the trajectory, movement of the different stages, all should be conducive to the man who is sitting inside. He should be protected. And if there is no protection and there is going to be a problem, he should be ejected out. So there's an ejection system also is there to safeguard the astronaut. So this is called man-rated system. And this we are now doing for sending the astronaut to the space. Then hybrid propulsion. So we have seen solid rocket, we have seen cryogenic rocket, we have seen semi-cryogenic, we have seen the liquid fuel, we have seen. Now hybrid, when it comes, it has got solid and liquid. How do you do it? So liquid is under pressure, solid is a fuel. So it is under pressure means it is oxidizer. This is the fuel. You can see the fuel rocket, which is the fuel. It is in particular shape it is put. You can see the fuel grain. And then you got the oxidizer tank. So here oxidizer can be N2O4 and the fuel can be even UDMH or even solid. So here we are talking about solid because it's a hybrid. So liquid is the oxidizer and the fuel is a solid. So that's a combination. So you can see the firing. These are small rockets, but normally we don't use hybrid systems. Another type of propulsion is called ramjet propulsion. That is you want to get more energy. What you do is you have a solid booster here. This is a booster. It burns like a solid rocket. Once it burns out, it becomes a combustion chamber for the liquid to flow or solid to flow. Solid, this is a solid fuel-rich propellant for the Akash missile. If it is a BrahMos, it is a liquid propellant. And then you have got the air ducts. So air comes in, rams it over the fuel flow. So that's why it's called ramjet. And this becomes the empty combustion chamber becomes the combustion chamber where the fuel is pumped in and the air is sent in a very high speed. So initial velocity, what you have to get for ignition of the ramjet is minimum 2 times the speed of sound. Sound speed is called Mach number, M-A-C-H, Mach. Once you say Mach number, Mach 1 is called sonic. That is called the speed of sound, 320 meter per second, 330, 20 meter per second. So this speed, you should get twice the speed of that, and then you have to ram the air, then only this ramjet will work. For ramjet, the minimum requirement is a high speed propulsion. It has to be there. By doing that, you get a specific impulse which is very high. So this is, you can see that the rocket, you can see, this is called Akash missile, which was used in Sindoor, Operation Sindoor, to defeat all the Chinese missiles which were launched against us. It went and intercepted. Also, the the aircraft which is coming towards us, you want to defeat the aircraft or destroy the aircraft, you have to send this Akash. This is a surface to air missile. You can see this pink color is the fuel, solid fuel. Initially, it burns like this. You can see the burning. And then once it gets a velocity, these caps are ruptured, air gets in, and this fuel, green is the fuel. It burns here, combustion takes place, taking the velocity to 2.5 times the speed of sound. So here it is Mach number 2.5. The missile goes, and it has got a high maneuverability. So even the aircraft turns, and the enemy aircraft, it also turns towards that and finish off. So there's a command guidance system which is operating, and there's a warhead. Warhead is explosive. Explosive is using the fuel. So you have the warhead explosion is done by a proximity fuse, but when it goes nearer to the enemy aircraft, the whole warhead explodes, and then the whole thing burns. Okay, are you following? Is it you are following? Yeah. Anyone can say yes or no?
Yes, sir.
Okay, okay.
Yes.
So then we have got a liquid ramjet. Like solid ramjet you have seen Akash. This liquid ramjet is one which gives much higher specific impulse. So energy wise, when I say 450 for the cryogenic, the solid ramjet gives 600. And liquid ramjet gives 1200. That means 4 times energy you get when you go for liquid ramjet engine. So this is the engine used for BrahMos. You know BrahMos, you must have heard about BrahMos. I will explain to you in detail BrahMos in the missile class. But what I am trying to tell you is that like this, you can see this diagram. So it has got a, initially it is a solid propellant burns. When solid propellant burns, this becomes empty, and there the liquid flows. The liquid is stored here. This is the liquid. Liquid is kerosene, aviation kerosene. It's pumped in, and the air comes from the nose cone at a very high speed, and the combustion takes place here. And it gives energy, enormous energy it gives. So we need an engine which can give supersonic engine. The only engine which is available in the whole world is this engine, what you are seeing. This is a Russian engine. They have made it during Soviet Union stage. This is called supersonic engine. It gives the supersonic speed to the missile. So is this missile, I think, the energy wise, I have just plotted how much energy it gives. So this combustion takes place by opening the inlet, allowing the air to pass inside, and the kerosene, the fuel is injected minutely, atomized injection takes place in the combustion chamber. So then the whole thing becomes an energy which is sent out. So when you see the launch, you will see that difference. Now next stage, this is 1200 seconds I have told you, 1200. So solid is 300, cryogenic is 450, then ramjet solid is 600, liquid ramjet is 1200. There is another thing called scramjet, which is 3000. We want to get such a very big energy, you have to go for scramjet. When you say scramjet, it is called supersonic combustion inside. Inside supersonic combustion, outside will be beyond Mach 5. This is called hypersonic. When the speed of the missile exceeds 5, it becomes hypersonic. Okay, this is the hypersonic missile you can see. So here this very important development which we are doing now. The hypersonic is very important. This is what is required is called the scramjet propulsion. India is the only country which has achieved 1,000 seconds of combustion in scramjet. No other country has achieved. So we are now on the move to make a missile which can fly for a long time with a very high velocity, hypersonic velocity. ISRO has done the scramjet in a small rocket. They have done. They have conducted it very effectively, and the scramjet engine burned for 26 seconds. But there is still a lot of things to be achieved. We have achieved ground on the ground we have achieved 1,000 seconds, but we have to achieve it in the flight. So the main thing is the material. Because the temperature is so high, all material is completely eaten away during the flight. So you need a very good material, and the world does not have that much material. So world has got a lot of this hypersonic. Many people are doing, as the Americans are doing. You can see that there are different types of engine. This is a passenger aircraft with hypersonic speed. So this is the USA has done the Falcon single stage, then Space Lab. So ISRO has tried out this. Then what we are trying to do is this is a NASA hypersonic plane. What we are trying to make is called hyperplane. Our ultimate aim is to use it for a normal aircraft type, so that it can go 100 times, take off and land, and it can put heavy payloads, and we can build big platforms. We can build. That's a very in a cost-effective way. So the cost is very less when you go for hypersonic. So the efficiency is very, very important. Today, this is the efficiency where we have got is very high. We need $220,000 per kg is the cost today. We want to make it to less than $1,000 per kilogram of the weight. So these are for solar power, orbital transfer vehicles, nuclear waste disposal, space labs, manufacturing in space. So all these things have to be achieved. Extraterrestrial mining, then space colonization, bringing wealth from the space. All these things are the future requirement. So now let us understand something about the electric propulsion. I think this I will take in the next class. This is a very detailed, we'll consider this one. So I think we'll stop it at this point in the terms of propulsion. We'll go through one more class on propulsion, because we have to study how do we reach the speed of light. We have to achieve the speed of light. So I will take that class in the next time. Okay. So these are a lot of things are there in this. So now let us see some more things. Let us see, because where is it? Hello, can we ask you some questions? Can we go to question and answer session?
Yes, sir. Yes, sir.
We are now already 7. We'll take other things later, other points later. So we have covered the launch vehicle. Hello, hello.
Hello, sir.
You are able to hear, no?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay. I have some problem of internet, so I have switched over to my laptop. Okay, please ask question.
Good evening, sir. I am Bidashandra from class 9A, Velamala Vidyalaya, sir. Sir, I
Yeah.
have a doubt regarding our last class, sir. Sir, you mentioned about Russia, that is Soviet Union, releasing the earliest rockets, sir. Sir, my doubt here is how did they calculate the air resistance way back then, sir? They did not have any modern technology, sir. What kind of experiments did they do, sir?
So air pressure and all they know. So you have to, air is not at all important there. When you are talking about a rocket, air is not important. You are everything oxidizer, everything is inside the rocket.
Sir,
So
air
you,
resistance, sir.
air resistance, air
Ah,
resistance, air. See, that is why they model first the all the sounding rockets are made. I have talked about sounding rockets, they measure the different air pressure, air humidity, and then the wind speed. All these things are measured through various means. You have got balloon can go up, helium balloon, it measures the details. So there are so many measurement methods which have been done way back. It is not during the rocket. Much earlier, people have understood what is the atmosphere, different atmosphere, the different layers of atmosphere, everything is known. So all the details are available to them when they do the calculation of wind profile, everything they do. So wind profile can be measured by sending a balloon. Very simple.
okay, sir. Thank you, sir.
Yeah.
Good evening, sir. My name is Narmani. I am from Srimari Sundaravali Memorial School, and I have a doubt regarding the specific impulse of rockets. So, the specific impulse is measured in how many seconds the rockets burn, right, sir?
No, you carry some propellant, right? You solid or liquid, whatever it is.
Yes,
So
sir.
many kg of propellant is there. This kg of propellant, how much total impulse it can give? What is total impulse? The force. Finally, everything depends on the thrust which is generated by the rocket. So to do the thrust, you need, that is the thrust is measured by force. That is the total impulse. Force into time is the total impulse. Force in time is the total impulse, right? So when total impulse is calculated and divided by the weight of the mass of the propellant, is called the specific impulse. So much.
Okay, sir. And I have another doubt, sir. So ramjets and scramjets both have kind of the same structure, right, sir? So how does scramjet have higher specific impulse?
No, it is not the same structure. It is different structure. I have shown you. One is from the nose, just you are taking. That's one thing. Another one is the ram. You have to get a minimum of Mach 5. In the ramjet, you have to take a minimum of Mach 2 speed. Then only ramjet will work. For scramjet, you need minimum of 5 Mach number. Then only scramjet will work.
Yes, sir. Thank you, sir.
There's a difference. Okay. One is nose intake. Another one is called belly intake. Okay, next, Nirmanyo.
Just now I asked, sir.
Okay. Next question. To close your this one, then only next person can ask.
Sir, good evening, sir. My name is R. Sanjeev Kumar from Velamal Vidya from Surapeta, and I am studying in 12th standard, sir. Sir, my question is that why pumps are not used for monopropellant rocket systems, sir?
Why?
Pumps are not used for monopropellant rocket systems.
No. You need a pressure. Why pump is used? Pump is giving a pressure of the flow.
Yes, sir.
But if you are giving a pressure already built in the system, a high pressure air bottle is kept with the helium or nitrogen, that is pushing the fuel. The already pressure is there. Then you don't need the turbo pump. So that is why you are not seeing a turbo pump. It is just flowed down. It's just down. It flows down.
Okay, sir. I have another question, sir. Why ramjet systems are not used in modern rocket systems, sir?
Ramjet is used in BrahMos.
To space, sir.
Yeah. We are using it in Akash, which has been used in Sintur. That's a ramjet propulsion, solid ramjet. And then we used BrahMos, which is a liquid ramjet. Both have been used.
Okay, sir. Sir, why kerosene is used instead of hydrogen in Saturn V rockets, sir?
Hydrogen is not storable. In a missile, you cannot use hydrogen. Hydrogen is a very, is a very cold condition. It is there, very cold condition. So you cannot keep it for a long time. Missile is to take off immediately. It is not rocket. A launch vehicle, when you do a launch, you can prepare them and finally you do the launch. But in a war, you cannot do like that. You have to do it fast. So all the missiles are prepared before. So you cannot use hydrogen.
Okay, sir. Thank you, sir.
Sir, my name is Sheikh Adil from 9th Standard Velamal Metric, sir. Sir, before you said that cryogenic propellants have a high specific impulse and good efficiency, so they are used in a later stage of rockets, sir. Then, but why are they not used throughout the whole flight, sir?
You need a thrust level. The takeoff thrust should be very high. Then only the T by W. T should be much more. Then only the rocket will take off. The thrust you want to give more. In a cryogenic system, you cannot give that high thrust. For example, the space shuttle, there's got 3 engines of cryogenic, but they are burned, but it is not taking off. You have seen that launch. It is not taking off. When you put the 2 boosters, when they fire, only it takes off. So you need high thrust, which is not given by cryogenic.
Oh, okay, sir. Thank you, sir. Sir. Good evening, sir. I am SP Vojis, 9th Standard from Shishya Vidyalaya CBC School, Tiruvannamalai, sir. Sir, I am having a doubt that what will happen if the fuel reduces while the rocket is flying in upwards, sir?
See, fuel reduces means weight reduces. Weight reduces means speed increases.
No, sir. Then how can the rocket can go till the destination like moon like that, sir?
No, fuel goes on reducing. Fuel has to be used, then only that burns. You have to burn, then only energy comes, is not.
Okay,
when
sir.
you are burning, you have to use the fuel. Fuel will be going down. When the fuel is going to be 0, you separate out the stage. That's why you are seeing separation.
Okay, sir. Sir, and I'm having a doubt regarding yesterday's class, sir. Sir, you said the man sat in a chair and they tied 42 rockets, 47 rockets under the chair and they burned it, sir. You said he where he went, we don't know, sir. The rocket will go to a certain meter or distance. The rocket will blast or it will off, no, sir. Then he can come down by alive or non-alive, no, sir. How can he can miss, sir?
See, these are very early stage, very early stage when people don't know trajectory and all those calculations and all, nobody knows. When they have seen that something can take off, he wanted to experiment himself to go up and come. Like people wanted to fly earlier by putting that wings, different types of wings and then dying, Like that, this man thought he can go up and come down. But when that whole thing fired, it was pushed it up. So due to gravity, Earth is rotating. So you have got a speed for the Earth. So it went and somewhere it went. People don't know where he has gone because he has used so many rockets he has used. He went up. So we don't know. He must have died.
Okay, sir. Sir, if an example, if a rocket went to a moon and the fuel is 0, did they will refuel in moon or how, sir? How do they refuel in moon?
Rocket, when it is going to the moon, when it goes, it orbits around the moon. In the final stage, around it goes around the moon. Okay. Then we separate out the moon lander. We separate out from the main propulsion. We take out the lander and the lander goes down and it orbits around 100 kilometer and then finally lands. Once it lands, for returning purpose, there is another propulsion system in the lander which is used to fire. After the experiment is over, they want to come back, they fire it and it goes into the 100-kilometer orbit where already that is the propulsion is moving around. So it goes and docks to that and then the human being is saved and he comes back to the Earth.
Okay, sir. Okay, sir. Sir, and a last example. For example, where do they manufacture rockets, sir? Like NASA, ISRO?
Where we manufacture rockets?
Yes, sir.
See, we have got ISRO, ISRO. ISRO is
sir.
responsible for making all our rockets. So a rocket
Sir,
means
okay,
there's
sir.
a chamber. There's a chamber. Chamber is made by the industry. You know, we have got number of big industries are there in India where they make the different types of chambers they make. Then it goes to Sriharikota where they put the propellant inside, and then they make the rocket motor. They assemble their nozzle and the igniter and make it ready, and then stage by stage they assemble. Everything is done in Sriharikota, and then they launch it.
Sir,
So
they sense their
industries are there. There are many industries are there who make the rockets.
Sir, you are saying is that they sends the rocket parts by partly and they assembles there in Sriharikota on the launch pad or separately, sir?
Each rocket motor is assembled at Sriharikota in a place called SPROB. That is solid propellant rocket assembly station. Then each one is brought to the launch pad, and the launch pad there's a big mobile structure where each stage is assembled and the rocket is made there and then moved it to the launch point and then it is launched. We will see that later. I will show you.
Yes, sir.
Okay,
Sir. Thank you, sir.
Next.
Good evening, sir. I'm Sri Dhanlakshmi of 9th standard studying in URC Pillai School, Erode. I have a doubt regarding yesterday's class, sir. In the video, you have shown that in a rocket, when the center of mass is behind the center of pressure, the rocket is unstable. When the center of mass is before the center of pressure, the rocket is stable. What will happen when the center of mass and the center of pressure are at the same point?
It will tumbles. It will tumble. It will not go up. It will tumble.
Okay, sir. Thank you, sir.
Okay.
Sir. Good evening, sir.
Question.
எஸ் தர்சனப்பிரியா அரசு மேல்நிலைப்பள்ளி டி குன்னத்தூர் சார். வெற்றிடத்தில் ராக்கெட் பறக்குமா சார்? வெற்றிடத்தில் ராக்கெட் பறக்குமா?
வெற்றிடத்தில் தான் பறக்கும் ராக்கெட். See, very basic question you are asking. Rocket has got propellant, oxidizer, everything inside. It has nothing to do with outside. It burns inside and goes up. Whether it is a vacuum or whether it is a atmosphere, it will go.
Okay, sir.
Okay.
இன்னொரு கொஸ்டின் சார். கிரகங்கள் ஏன் விண்வெளியில் மிதக்கின்றன?
விண்வெளியில் மிதக்கின்றன இல்ல. There's a universe. We have got universe, right? Hello.
Yes, sir.
First
yes,
class
sir.
you are attending you attended the first class?
Yes, sir.
It is not floating. Everything is there. This is a universe. They are all going round and round. It's all moving, not floating. They are all moving. Okay. Next question. Next.
Sir. Sir.
So we have to complete it quickly. I have to go. Next question.
Sir.
Yes, please question.
Good evening, sir.
Yes.
See, you ask question. There's no time
Sir.
left for you.
I am PB Jaydev from 8th standard of Velamal Bodhi campus, Anupanadi, Madurai. Sir, my question is that what is the purpose of sensor package in the Akash missile, sir?
What is the purpose of what package?
Sensor
what package? Sensor package. Sensor package.
Sensor package.
Okay. See, you have to guide the missile to the target. Sensor is the one which is guiding the rocket to the target. It's called guidance. It guides.
Okay.
Next question. Next.
Good afternoon, sir. My name is P. Bajasan from St. Tanis Matriculation School, Block 20, Neyveli, sir. So I want to know what is my Mach number, sir?
Mach number is a scientist name. Mach is a scientist who has understood what is the speed of sound. So once you know the speed of sound, that speed of sound is the measurement for any comparison. Okay.
Okay, sir.
So speed of sound is called Mach number.
Okay, sir.
If you say Mach number 1 means it is speed of sound.
Okay, sir. And one more thing, sir. What is my Nepro plate, sir?
What?
What is my neproplate, sir?
What flight? Neftov.
No, sir. Neproplate. Neproplate.
What is spelling?
Sir, while teaching, no, sir, you say in cluster, no, sir, we are using neproplate, sir.
I have not to use the word nepro.
Okay, sir.
I didn't say nepra. Okay.
Thank you, sir.
Thank you.
Sir, good evening, sir. My name is Prasanna from Javagar Higher Secondary School, CBSE Neyveli, sir. I have a question in the previous class. What will happen if there is no oxidation in the rocket, sir? It will move or remains in same?
If there is no oxygen, burning will not take place.
Okay,
for
sir.
burning anything, you need oxygen.
Yes, sir.
Is it right or wrong?
Yes, sir. Thank you.
So you need oxygen. If you remove the oxygen, you put only a fuel which burns, it has no effect.
Okay, sir.
It will not burn also. You need a combustion to take place. Combustion is very important. That only will give energy finally. Combustion will not take place if there is no oxygen.
Sir, we have another way other than oxygen. We have another way to add any compounds.
There are so many things, plasma, so many laser, so many things are there.
Okay, sir. Thank you, sir.
Okay.
Sir, good evening, sir. From Jeevana School, Madurai. So I have a question for you, sir. Does the speed differs from the Earth and the space, sir, of the rocket?
Pardon?
Does the speed of the rocket differs from the Earth and the space, sir?
Steel of the Earth.
Speed, sir. Speed.
Speed of the rocket.
Yes, sir. Differs from the Earth and the space, sir.
Yes, definitely. Why it differs? You tell the reason. There is a force called gravity.
Yes, sir.
Okay. So you are fighting against the gravity to go during the atmosphere. So you need a long, big force to go up. But when you go to space, it's vacuum. There's no resistance. So the speed will be different if you use a force. So a small force can take the rocket for a long distance. So vacuum speed is different from speed in the air medium.
Yes, sir. So I have one more question for you, sir. Does the can we replace the?
Does that what?
So can we made a rocket? Can we make a rocket by solar panels, sir?
Yeah, solar power rockets are there.
Oh yes, sir. Thank you, sir.
Okay. Next question.
Good evening, sir. I am Esashida. I have a doubt, sir. Sir, you have tell the GSLV that goes in the geo orbit. ULV, what it goes in what orbit, sir?
ULV. There's no ULV.
You had shown the two rockets.
One is called PSLV, another one is GSLV. PSLV puts a satellite in the polar orbit. GSLV puts a satellite in a geostationary orbit.
Okay, sir. You have told the propulsion of many things. Which is the speediest propulsion, sir?
No, not followed. What did you ask?
You had tell many propulsions.
Many?
Propulsions.
Propulsion. Word correctly is spelled. Propulsion. Tell again.
Propulsion.
Propulsion. Different types of propulsions I have told you. Yes.
Which is the speediest propulsion, sir?
Speed of the propulsion also I explained to you that the speed is there are different things are there for speed. But what is important is the energy. Energy is important. Energy is measured by specific impulse. I explained to you what is the specific impulse of each propulsion. That is the one you should know. Don't worry about the speed. Speed depends on various other factors.
Okay, sir. Thank you, sir.
Okay.
Sir,
Next.
good evening, sir. I'm Harini from St. John's Metric School, sir. Sir, I have a question that if satellites launched from Earth stay in orbit by continuously falling under gravity, then how does a spacecraft sent to Mars escape its gravity and enter Mars's orbit instead of just orbiting it forever, sir?
Very good question. See, when you launch a rocket,
yes, sir.
If you want to achieve something beyond the Earth's rotation, you want to that is called escape from the Earth. You want to do, then what you have to do? You have to first go orbit around the Earth, and then you have to give a specific impulse. You have to give push. You have to give propulsion, which should take out beyond the escape velocity. That means the velocity requirement for escape is much higher than orbiting velocity. If your satellite, if you want to put and orbit, you need minimum 7.9 kilometer per second. If it without that, the satellite will not orbit. But if you want to orbit in higher orbit, like this geostationary orbit, you have to go for 13 kilometer per second. You have to go. But beyond that, if you want to go, escape from the Earth, you need more velocity to be given. At that point, when you do that circle you are doing, you give a specific impulse, a higher specific impulse. You have to, you have to give a push. You have to give thrust. You have to give escape from the Earth's gravity. So once you go there, it is called Hoffman transfer. You go long distance. Go to suppose you want to do around the moon, you have to now reach a stage where Earth, moon, both have got gravity.
Okay, sir.
At one point, the gravity becomes zero. Because the Earth's gravity and moon gravity, they meet together at one point. That is called Lagrangian point. At that point, you should give another kick. You have to give propulsion. Then it will go around the moon. So similarly, for going to Mars also, we need to travel a long distance. Some millions of kilometers you have to travel. And when you go very near to the Mars, then the point of equation, the equal gravity, you have to give a push, then it goes out and then goes around the Mars orbit. Once it goes to Mars orbit, it will be going around Mars, and then you can do a lot of things you can do. You can eject a rover, and the more rovers are going on the Mars.
Yes, sir. Yes, sir. Yes, sir.
That is possible. All these things are possible. So main thing is called escape from the Earth. That is one is very important.
Sir, I have one more question, sir. Sir, we can just use more explosive fuels in the propellant tank instead of using, like, we can use antimatter. It's extremely explosive, and that would require lesser energy to push off the rockets. So why don't we use them, sir?
See, in the case of takeoff, when you do takeoff, when you do the Earth gravity, when you want to take off, you can't use any other propulsion except the chemical propulsion, because you need large thrust to take off. So we use chemical propulsion. But when you go into the vacuum level, orbit, when you go, you want to put a satellite in the orbit, you have gone much beyond the atmosphere, then you can use different types of propulsion. I have told special propulsion, I have just talked. Nuclear propulsion, laser propulsion, the solar propulsion. There are so many things. We will be talking about that later. Electric propulsion. So many things are there, which are much beyond, but very low thrust only it can give.
Yes, sir. Yes.
High thrust. There, the intention of using such propulsion is to travel long distance. We want to travel for long distance. You want to go light year speed. You want to cross 1 or 2 light years. If you want to cross, you need a propulsion which is not chemical propulsion, which will be different.
Okay, sir. Okay, sir. Thank you, sir.
Thank you. Thank you. Thank you for the question.
Sir?
Hello, sir.
Yes.
Sir, good evening, sir.
Hmm.
Sir, I have yesterday class. I have one doubt, sir. So, why they using gunpowder in the rocket, sir?
We don't use gunpowder. That was used at the beginning stage. Not now. Now nobody uses gunpowder.
Okay, sir. Sir, I have another doubt. Sir, universe not have no gravity, sir.
Universe has got gravity. Who told no gravity? Universe has got 4 forces, physical forces. You are not listening properly.
Sir,
Okay. Next question. Next person.
Sir, sir, myself Badrinath from GK Shri Vivekananda Vidyalaya, sir. Sir, my doubt in BrahMos missile, a supersonic missile, will it able to change its direction in the high speeds in high Mach, sir?
Yeah, you can do that.
Yes, sir. Another doubt, sir. When the rockets are going out of the Earth and reaching the Moon or the Mars, how it overcomes the space debris all over the Earth's atmosphere and outside the Earth, sir?
See, there is no atmosphere we are talking about on the moon.
Yes, sir. Not atmosphere. Sorry, sir. Sorry, sir. About the space above the Earth, sir. Space debris.
That is space debris you are saying?
Yes, sir.
Debris are there, yes. What do you want to know about debris?
Yes, sir. How does the rocket or the satellite overcomes the debris and orbit around the Earth?
Debris, you know, there is all the debris are known where they are. Okay. There is a completely monitored. So when they do the launch, they will launch such a way that the sequence of the launch, some stage when it goes up or satellite goes up, it should not hit the debris. So that is calculated and then only the launch time is fixed.
Okay, sir. Thank you, sir.
Sir, I am Pranav from Adhyapana School, Madurai. I have a doubt. We need to keep the oxidizer at a very cold place, and when it comes to the reaction, it burns and it creates hot, sir. How does it prevent the hot air not to go inside of the rocket?
It is coming out through the nozzle. Where is the rocket? It burns in the combustion chamber, which is sealed, and it is pushed through the nozzle. It doesn't go to the rocket. Rocket is a big one. Combustion chamber, the whole thing happens where the temperature is very high and the exhaust comes out. It comes out to the nozzle. Nozzle is leaving the air, the gas outside.
Sir, the nozzle does not have any boiling point or that.
No, nothing. That is designed for that. A different material is used.
Okay, sir. Thank you, sir.
Next question.
Good evening, sir. I am Agathiar of KSR High Tech School, sir. I have a general doubt on rocket science, sir. I am very passionate about space and inspired of ISRO, sir. Which course at college should I choose? And how can I prepare to become a scientist or engineer at ISRO?
So you study properly in what you are doing, get good marks, then we'll see after when you complete 12th standard, I will tell you what to do.
Thank you, sir. Okay, sir.
Okay, shall we close the discussion, Dr. Balmurugan?
Yes, sir. We can close it, sir. By next week, we can continue, sir. Yes, sir.
Okay, right. Thank you very much.
Thank you so much, sir. Thank you so much, sir. Thank you. Students and coordinators, so please, there is a announcement. So please wait for announcement. Please wait, sir, until. Okay, so sir has left. So thank you so much for the participants. So and thank you so much for your discipline that you are maintaining. So while you raise your hands, if someone is asking, and once the question is over, you got the answer, means you need to put up your hands also. So because raising the hand, going on raising your hand, so that might also make a confusions. So that is one part. So today we have an attendance sheet. So the attendance sheet should be shared in the group. So ensure that all the students and coordinators, mainly we need the coordinators to mark the attendance. If at all the attendance is not marked, by next week you may not have eligibility to attend the courses, because the 3 consecutive meetings if you are missing, and then you would be removed from the course itself, because you don't have the opportunity to share the link. And also we just wanted to have the people need to join with their email ID. Whatever email ID you have registered, you need to come in through your registered mail ID alone. So that is very much important. And also, whenever you are listening to the lecture, so take up the screenshots and make a PPT in your home itself and have a notes of it. Going on, we know that you have an enthusiasm and you want to speak with the legend. So you are asking some questions. So it may be silly also. That is not the point. I just want to pinpoint. But ensure that you have questions very clarified and you written down in your notebook, so that when you read out, you need to have the clarity. Don't be in a haste to ask the question or put up the question in a different way. So like your sound and mic system should be working fine. So ensure that you are not having your earphone. So when you are talking with your earphone, the sound would be very feeble and sir may not understand the questions. So ensure that you are talking with your directly through your mobile or your laptop. Unmute yourself, wait for your chance, and then raise up your question. Once you get the answer, you also give equal opportunity to the other students. You might have 10 to n number of questions. That is not important right away. So make sure that you are asking one question at a time. Maybe it can extend to 2 questions, not more than that, because everyone need to have equal opportunity. So I'm not denying that many students would be having doubts, but still, if you have doubts, ensure that you are restricting your questions to 2 numbers, not more than that. That is very much important. So today we are closing this session today. So we need to ensure that the attendance is being marked. 2 days has been given to in the attendance sheet. So the coordinators ensure that you are marking the attendance for all the students. So we come to know that many of the people who have registered have not attended the classes. Those people who are attending have not registered in the form. So ensure that you are registered in the registration form as well as completed your examinations and you are attending the class. These two to three classes might be maybe you have skipped it or you may not have joined. So but from the next class, ensure that you are having a number code which is assigned to you. So with the number code followed by your name and then followed by your school name. It's not that you have your own way of writing your name or naming convention. So the convention is given to identify yourself. You need to adhere with the principles. It's not that we are going on telling some instruction and you don't have a don't care mind. Please ensure that you are adhering to the principles. If you have any doubts, you can clarify then and there. So equal opportunities would be given to many such people. Today also, I just don't wanted to provide opportunity to people who have not named it, but still today I have given it for Shreya. But we need to ensure that you are coming with a naming convention, because many people are having the discipline. If 1 or 2 people are not adhering the principle, means someone is been punished because of you people. So ensure that you have a discipline procedure. Thank you so much. If you have any doubts right away, if you have any doubts, coordinators, please, you can unmute and you can ask. Coordinators, please raise up your hands. Yes.
Sir, you send the PDF in WhatsApp, sir. We copy them.
Which PDF, ma?
Sir, you send now, sir.
I have sent any PDF to you? No, I have not sent any PDF, ma. What's the PDF?
WhatsApp, sir.
Uh-huh.
In WhatsApp. Rocket Science group. In
No,
Rocket you send.
we have not sent any PDF document, ma. What is that?
Sir,
okay, so the PDF is to know your number. That's it.
Okay, sir. Okay, sir.
Brochures, huh? Okay, fine. So that is different. So now the coordinators, you have a coordinator, right? So ensure that your coordinator is marking the attendance today itself. Okay. So for the last 2 to 3 classes, they need to mark it. So ensure that your coordinator is marking it. If at all hey, you don't have coordinator, So please contact Dr. Rajalakshmi ma'am. So who is the coordinator? She would be guiding you in marking the attendance. Okay. So how many people have coordinator? How many people doesn't have coordinator? So we need to ensure that we are having a handshake. So that is very much important. So Dhanush. So what Dhanush? Dhanush Sri Priya. Yes, ma. Please unmute yourself. What do you want? Okay, so if no one has doubt, so we can close it up. So today we need to mark the attendance. That is very much important. So you need to mark the attendance. Your coordinator need to ensure it. So coordinators, please cooperate and ensure that it is running smoothly. On a regular basis, we could not update it. So we also have some commitment to ensure that all these kids are following up with their lesson plan and they have the doubts clarified then and there. So the legend is taking up the class. So that's where we wanted to ensure the discipline. So the discipline is very much important. It's not the student's name, it's also the school name which is going to be spoiled because of your own activity. So ensure that the students are maintaining discipline. That is being followed by the coordinator. The coordinators ensure that the attendance and the lesson plan is followed up. Once the 10 session is closed up, 10 to 15 sessions, accordingly, we would be having a fast track to ensure that you are moving towards the second stage. Okay, so this is the plan of action that has been shared. So we would be following our lesson plan scrupulously. So we also request all the students to attend the classes regularly and have a note of each and everything. Thank you so much and have a good day, good week ahead. Thank you so much. Thank you. Kabilan, you can close it up. Thank you.
Thank you, sir.